Hello, everybody, and thank you, Dean, for the kind introduction. I basically present some of my research topics. So basically, these days we are working on 6G, and we are essentially trying to go beyond what we have right now. So what we have right now is 5G. So to go beyond that means in terms of data rates, I think when you get your mobile phone, you have a certain megabit per second. So we want to go higher. Some people throw, let's say we go to hundreds of gigabits or terabit per second. So there is one side, and we certainly want to connect more people. There are unconnected people, billions. So we want to get them to connect to the system. And also, increasingly, there are machines. So not just, it is more than just connecting people. Also, a lot of machines are being connected to the system. So machine-to-machine communication is there. And that way, we also provide people with better immersive experiences. And also, some people say, okay, there will be holographic communication. So artificial intelligence will play a role in that. So my research is focused on what we call AI interface, where we consider, for example, a mobile phone. When we take the phone and then transmit the signal to the base station, it then undergoes various changes. So this wireless channel from the transmitting point to the reception has a lot of properties that we need to study about statistical characterization, whether you have particular line of sight or non-line of sight, fading, and those phenomena. So that is coming under this, what we call statistical communication theory. I'm basically teaching a course in that area. And now moving on from that, and we said we are going beyond. So beyond to the higher frequencies. When we go higher and higher in terms of frequencies, these coverage distances, how long you can transmit the signal becomes shorter, and your antenna beams become narrower. So because of that, you need to focus more on the area where you are going to transmit this. And that implies we have to know where the user is located. Localization has become an issue. And at the same time, the antenna dimensions become smaller as we go high in frequency, so we can pack more number of antennas into the mobile phone as well as to your base station. We call it massive multiple input, multiple out systems. And importantly, we now consider that rather than user being connected to a particular base station, we will have what we call cell-free situation where you are connected to more than one base station. So that kind of scenario will bring forth new things to investigate. And accordingly, as mentioned, so things are uncertain when we have narrow beam widths. So we have to know about the environment. And that means we need to know, we need to have sensing incorporated into the system. And maybe you have heard in, for example, these autonomous vehicles, you have a LiDAR to detect the objects in the environment, and also radar that we are normally familiar with. So we need to incorporate these systems, or sensing, for example, will be a key feature that we expect in this 6G system. So that is one thing that we have to consider. And also, as I mentioned, this wireless channel, when we are transmitting a signal till the receiving point, undergoes many things. So that means errors can happen. So the bit stream that you are transmitting will have to be coded in some fashion. So this error control coding is again something that I am focusing on. Traditionally, this was coming under the area of information theory, which was originally formulated by Shannon. I think a lot of people have heard about him. And now a lot of development had taken place since that time. And now there is also this area where we have what we call semantic coding in the environment. And that can be considered also coming into communications in the sense of semantic communication. So that could be another area that is under exploration right now. So to do all these things, you are moving from statistical techniques to this signal processing techniques to implementations. And we have, like I said, a lot of these sensors providing data. You have a large number of data to deal with. So that means we are going to use machine learning methods to implement most of these things. And that is actively under consideration, as you had heard. So along with these machine learning methods, it also means that we need to have our researchers trained in these things, in these fundamentals, to provide the proper background for them to carry out this research I have mentioned in these different topics. So coming to industry from this research, therefore, the manufacturers are taking steps to standardize this research into a common system. So that is undergoing right now in these 3GPP organizations, and what is happening, what is going to happen beyond 5G, and eventually it will lead to 6G standard somewhere around 2026. But then these will be implemented, these technologies will be implemented by the operators who spend billions across the world to acquire spectrum, because the spectrum is is sold by the regulators or governments at very high expenditure, perhaps not so much in Finland, but in other places. And in addition to this situation, we expect these bigger operators to be there, but also we expect there will be small operators. For example, our University of Oulu has a test network, which is also connecting general connections as well as sensors, providing a lot of data. So this kind of small operators we expect to also evolve in when these 6G systems come into place. And these things should lead to, let's say, enhancing different vertical industries like automotive sector or agriculture, health sector. For example, University of Oulu Hospital is a key testing place for wireless techniques with 6G. So with that, so there is a industry point of view, research point of view. Then what are the expectations of our society? For example, you had seen or heard the news that Artemis rocket launched Orion spacecraft to orbit around the moon, and they are planning, for example, interplanetary explorations and settlement in moon and so on. And I think Nokia had advertised, okay, come join to build communication for moon. So there is, on the one side, things going well, but on the other side, we also see the climate situation, climate crisis. So we have to provide climate sustainable solutions. Recently, there was this COP27 conference on that. And more importantly, closer to home here, there is the looming energy crisis, electricity crisis. We are supposed to save energy. So how to provide energy efficient solutions through this 6G, how to switch off base stations if they are being not used. So those are the things that need to be considered, and especially to consider supporting Millennium Development Goals, where we have a lot of these, about 4 billion people unconnected, how to connect them to the network with, for example, terrestrial networks or together with these satellite constellations, for example, Starlink. So how to get this thing done so that we can provide, let us say, information for the decision makers as well as to the general public, so that people have what they need. And that is actually the, let's say, overall facilitation that if we can do it. And also it should show to these young people, those who are willing to work in these areas, to come in to wireless communications and study and come up with new innovations. So that is another thing that we have to accomplish. So that's basically in a nutshell that I wanted to discuss. So thank you for your attention. And last but not least, I wish to thank all my colleagues in CWC and the university, as well as my wife and family. Thank you. Thank you for your attention.